Hi everyone, in today's lesson you will learn how to calculate independent probability. By the end of this lesson you should be able to calculate the probability of two events occurring independently. Okay, so what is independent probability? Well, two events are said to be independent if the fact that A occurs does not affect the probability of B occurring. Some examples of this. So landing on a head when tossing a coin should not affect the probability of you rolling a 6 on a dice. So these are said to be independent events. Choosing a queen from a pack of cards, replacing it and then choosing an ace, that they should have no effect on each other because you've put the queen back in the pack, so there's 52 cards again. So how do we calculate the two events A and B when they're independent? The probability of both of them occurring is probability of A multiplied by the probability of B, okay? So the probability of A and B occurring is the probability of A multiplied by the probability of B. So let's look at a couple of examples here. A coin is tossed at the same time as a 6-sided dice is rolled. Find the probability of a tail and the number 4 appearing. Now we know that if we toss a coin that has no effect on the outcome of rolling the dice. So we know that this is independent probability. So let me first figure out what the probability of the tail is. So remember, on the bottom of the fraction it's the number of possible outcomes. So we could either land on a head or a tail, so that's 2 outcomes. How many of them do we want? Well, we just want the 1 because we want the tail. The probability of number 4 occurring, well, there's 6 faces that the dice could land on. We only want 1 because we only want the number 4. So the probability of rolling a 4 is 1 over 6. So the probability of landing on a tail and rolling a 4 is a half multiplied by 1/6. Now remember how to multiply fractions. We look to see if we can cross cancel down. We can't here, so then you just multiply straight across. 1 times 1 is 1, 2 times 6 is 12. So the probability of landing on a tail and rolling a 4 is 1 over 12. In example 2, a card is chosen at random from a pack of 52 cards. It is then replaced and a second card is chosen. What is the probability of choosing a king, then a 10? So the fact that we've chose a king should have no impact on whether we choose a 10 because we put the king back into the pack. So then we have the exact same chance, okay, for the picking of a 10. So the probability that we choose a king, well, a deck of cards has 4 suits and every one of them has a king. So that is 4 over 52 since there is 52 different cards in that deck. Now remember, if you can divide down, you should. Both of these numbers are divisible by 4. 4 goes into 4 once and 52 13 times. So the probability of picking a king is 1 in 13. The probability of picking a 10, well again, each suit has a 10 in it. So 4 out of 52 cards, and that will again simplify to 1 over 13. So if we want to figure out the probability of picking a king, replacing it and then picking a 10, we need to multiply the two of these together. 1 times 1 on the top is 1 over 13 times 13 is 169. So the probability of picking a king, replacing it and then picking a 10 is 1 over 169.